We class ourselves as venture philanthropists. That means we support new ideas which maybe wouldn't be supported, maybe a bit risky. And with our approach, we deal with all the problems that occur. Nothing could illustrate this better than in March 2020, when, having seen the virus the other side of the world, we thought it was not going to affect us, but it turned out to be a pandemic. The team got together. We said, we've got to find some COVID research. In a very short space of time, we looked at 60 projects. We had expert reviews from you out there. And from the 60, we chose 25 projects. We had them up and running in no time at all. And some of them even reported that year. Today, we are very fortunate to have 4 of these outstanding researchers with us. And very shortly, I will be passing you over to Professor Roger Barker, who will chair the afternoon. We will be taking questions. And if you have a question, make it short and sharp, and we will hopefully get short, sharp replies. As I'm at the front of the queue, I'm going to ask first. The government committee has just reported and said that both the government and scientists fell short of what we should have done. They've compared us to Australia and New Zealand. Is that fair, considering they are very sparsely populated and we are highly populated? Over to you, Roger, and let's enjoy the afternoon and learn. Goodbye.
So thank you very much, Richard. First thing I would say is I'm clearly not Anne, so I'm just going to rename myself. I'm Roger Barker. I am a neurologist in Cambridge, and my contribution to COVID was A, not to get it, and B, to look after the neurology patients who had COVID as part of the hospital. So as Richard says, it's a day when we've heard about some of the major errors which seem to be made in the management of the pandemic, but also some of the great successes that have taken place. And part of those great successes we obviously know about in terms of vaccines and such like, but you're now going to hear about other great successes from our speakers here this afternoon. So rather than me just ramble on, because we've got a relatively short period of time, I'm going to start straight away with Rebecca Shipley and Mervyn Singer. They're going to be talking about the UCL Ventura CPAP device. They're sitting together, probably not 2 meters apart. But Rebecca is the Professor of Healthcare Engineering at UCL and Director of the UCL Institute of Healthcare Engineering. She won the Rosetrees Trust Interdisciplinary Prize in 2016, has received an OBE for her COVID-19 research very recently. Mervyn has looked after the ITU, I think, at UCL, which has been normally very busy and even busier than normal over the last 18 months. And he's done much work, especially around sepsis. So it's great that you're with us. We look forward to your talk. And when, just for those listening, if you can put your questions up, then we can obviously ask some questions at the end. And then right at the end of all 3 talks, we'll have some more questions if we have time. So over to you two.
Lovely. Thank you very much indeed. Hopefully you'll be able to see the screen. Delighted to join you today. Thank you very much indeed for the invitation to Rosetrees, and obviously Becky and I will do a Cox and Box. We'll intermingle our 10-minute talk. So this is our talk talking about the CPAP device. And if you recall those heady days in spring 2020, there was a lot of doom and gloom in the media and the problems facing the UK. And certainly our backs were very much against the wall. Modelling suggested we'd need up to 40,000 ventilators. The problem is we only have 3,500 ICU beds, and neither for love nor money, because we were being gazumped by the United States, there was a worldwide shortage of ventilators, let alone the staff to look after them. Our Prime Minister decided clearly to invoke the Battle of Britain spirit and build more ventilators, so he appealed to British industry to make these. However, in my humble opinion as an intensivist, this was absolutely not the answer. Firstly, these patients are difficult to ventilate at the best of times. So to expect non-medical companies to make sophisticated ventilators within weeks to cope with the expected surge was, I think, totally unrealistic, notwithstanding the fact that you need staff to be able to look after them. And again, we suffer normally from a shortage, let alone coping with a 5 to 10-fold increase. So clearly, what's the answer? Keep them away from a mechanical ventilator. And here you can see a tabloid, the Daily Mail, Italy in hell, written in weeks. And you can see they had 3 patients side by side having a non-invasive respiratory support called CPAP, continuous positive airways pressure. And essentially you, under high pressure, so you drive it off the oxygen supply and you can entrain air to get the desired oxygen concentration that the patient breathes in and out from. And then instead of exhaling to atmospheric pressure, there's a valve against which they breathe, and that keeps the lungs splinted open, and that improves oxygenation. And therefore, without needing to resort to a ventilator, it can improve the oxygen levels in the blood and hopefully keep many of these patients away from the ventilator. We had no machines available to purchase, though. Again, there was a worldwide shortage. So let's make our own. I'll just quickly tell you about this device. So this was something that was used. I used it many years ago when my hair wasn't quite so grey. It's a purely mechanical device. It doesn't have fancy electronic circuits. Philips marketed it. It was now out of patent, but it's a very simple to operate device. And we thought, well, can we re-engineer this? We could get it approved by the regulatory bodies quickly. And clearly the questions were, could we make them? Could we make them at scale? And especially as we were entering this global lockdown. I'll now hand you over to Becky.
Thanks, Mervyn. So our team first came together on the 17th of March, 2020. Feels like yesterday and an awful long time ago at the same time. And we knew from the beginning that if we were going to be able to move quickly, we really needed a kind of trio of expertise, if you like. We needed engineers, so design engineers, and we had an excellent team led by Tim Baker, who's a professor of mechanical engineering design here at UCL. We obviously needed the healthcare expertise, so the knowledge of how to treat patients and how these kind of devices needed to operate when they were in hospitals. And of course, that was led up by Merv here, but also Dave Brearley, who's another consultant at UCLH Intensive Care. And then the final piece of the puzzle was the manufacturing expertise. So once we designed and made a prototype, who were going to be the manufacturing powerhouse that could make these in volume in a crisis. Now, Tim had a long history of working in the motorsports industry, and he reached out to Mercedes high performance powertrains, who are the arm of Mercedes Formula One, who design and make the Formula One engines for the racing drivers like Lewis Hamilton. Now, the Formula One had been stood down because of COVID, so their whole factory was in theory available, and they were magnificent. They joined the team immediately and became our manufacturing powerhouse. So I'm just going to talk through the timescales of what we did. And, you know, speed was really a driving factor. We came together on the 17th of March, and the peak of the first surge of COVID was due to hit London by the Easter weekend. So we had weeks if we were going to be able to do something meaningful to help the NHS. So Mercedes HPP turned up at UCL the next day. We bunkered down in our engineering design studios, which are part of the university. Now, we knew that if we were going to be able to get something into the NHS, a key component of that was getting regulatory approvals. So the MHRA are the regulator in the UK. We reached out to them on the 19th of March and also the Cabinet Office. Within 100 hours of our first meeting, we'd gone through the complete reverse engineering process to essentially replicate the Whisperflow CPAP. And Mercedes had made a first prototype, and we had them back in the hospital at UCLH. It was a Sunday evening, testing, plugging them in the wards and seeing how they behaved. On the 24th of March, due to a lot of work by Mervyn and a lot of colleagues, the NHS care pathway changed to include using CPAP to treat COVID patients. And on the 27th of March, that's 10 days from our first meeting, we had submitted all of the dossier of our device. So all of the details of bench testing and its performance in hospitals and on healthy volunteers to the MHRA, and we received approval for that Mark 1 device, which was a complete replica of the Whisperflow. We then started clinical evaluations, first at UCLH and then across sister hospitals in London. and the story hit the press at the end of March, around the 29th. Here are a few extra pictures, including a very glamorous one of Merv on one of the devices in the medical physics unit, I believe, at the hospital. Brilliant. So moving on from that, we got an order from the Department of Health. They commissioned 10,000 of the devices, but they needed to be delivered, well, within weeks. So Mercedes HPP took that on. At the same time, we were doing a lot of work to think about evolving the design, essentially to minimize how much oxygen it used. And that was because there was a real fear at the time that our hospitals could run out of oxygen. So we redesigned things like the air entrainment port to minimize how much oxygen was used by the device. And we managed to reduce that by up to 70%. So this Mark II device was then approved by the regulator on the 2nd of April, and that's what went forward for mass manufacture. As well as the actual CPAP device, we needed to think about all of the extra components that are needed for it to be used safely, including things like oxygen analyzers and breathing circuits. And of course, because of all the same reasons, there were real supply chain issues for all of these components as well. So we ended up partnering with a range of other companies, including Oxford Optronics, to make things like oxygen analyzers. We released all of our designs open source on the 6th of April, and I'll return to that a bit later on the talk. And ultimately, we delivered the 10,000 devices made by Mercedes HPP at a maximum rate of over 1,000 a day. They were delivered on the 15th of April and started going out into the NHS to hospitals around the country. This really just summarizes the timescales again. I won't go through again in detail, but really just to reiterate that this whole pipeline would normally take years really for developing a new medical device, testing it, providing all of the data, doing clinical evaluations and rolling out into the healthcare system. Because of the urgency of the situation and the fact that so many bodies really pivoted all of their processes to focus on speed and safety, we were able to do that in a matter of weeks rather than the years that we would normally face. So finally, as I mentioned, we had to partner with industry to make a range of devices that go with these CPAPs. And ultimately, we received 6 special authorizations from the regulator for 6 different medical devices, all manufactured at scale by working with industry, small and large, across the country.
This is one patient, you know, as an example, has it made a difference? I'll come back to that in more detail, but this is a little clip from the BBC, and this is a patient we had on our intensive care unit here, and as you can see, he's working hard, he looks tired, and there's the device in action at his bedside. And at the time it was 50 hospitals, and now in total 125 hospitals have been supplied with the devices. And as you can see, there's a nice happy ending. So after 4 weeks, he was well enough to go home. A bit shaky.
I would have thought you're probably still feeling a bit weak.
Well, I'm feeling quite good at the moment. Daytime, my life is like as if it's normal. But I get over there by relaxing myself and breathe.
Thank you. Nobody will happen to
Thank you, we got him home. All thanks to you.
And as you can see, these are other news clips. And again, like Ertan, many patients were kept away from ventilators, and thankfully were able to go home. Lots of places, these are just UK studies around the country, reported their experiences of using CPAP in patients with COVID. And just to show you a little bit of data, we have a national body that collects all UK data, in all intensive care data in England, Wales and Northern Ireland. And the graph goes on the x-axis from the beginning of the first surge to the end of the first surge. And you can see the need for invasive ventilation fell dramatically. So at any point, you were looking at 80% of intensive care patients. By the end of the first surge, this was down to 50%. The duration of invasive ventilation stayed essentially the same in those needing invasive ventilation, that you can see there's this big drop in 28-day in hospital mortality and in the survivors, because if you go on a ventilator, that unfortunately subjects the patient to quite a long stay in intensive care. We were able to improve the efficiency. There's been this randomized trial done in the UK as part of the recovery stable. 1,272 patients were enrolled, and CPAP compared to patients being left on an oxygen mask, there was a significant reduction in this composite outcome of need for intubation or mortality within 30 days. I'll hand over to Becky for the last few minutes.
So the final piece in the puzzle has been our international work, and this is an area that is still very active. So, you know, once we got press interest around the story, we suddenly started getting a lot of approaches from other countries who, for the same reasons as the UK, needed access to non-invasive ventilators. So we decided to take a humanitarian approach, and we released all of our designs and manufacturing instructions for free through a zero-cost license, so that other countries could download them and set up local manufacturing hubs to serve their own healthcare systems. So these give you a few stats on where we've got to with this so far. So we've approved over 2,000 requests for the designs, and that's over 105 countries. There are now 25 countries that have gone through the full journey of manufacturing them in country and actually getting them into use in hospitals there. So that's obviously really pleasing. And around 24,000 devices have been actually manufactured in these local manufacturing hubs in other countries. Another area that we've put a lot of effort into is enabling the devices to be donated to low and middle income countries, and that we've done through a range of charities. So charities like the International Medical Education Trust, who have donated devices into, for example, Palestine and Uganda. But we've also done a lot of work with governments. The UK government in particular has now donated quite a large number of these devices to countries in need, especially since the growth of Delta. And this gives you just some visuals of some of these devices in action and some of the other teams. We've learned a huge amount through this work, and there's an awful lot to be done. I think, if anything, it's highlighted as much the ways in which we really need to come together much better during a global crisis like this pandemic, to help each other. And I think it's an area that we'll all be continuing to focus our efforts in. So finally, just before we close out, here's a couple of testimonials from people in other countries. So the top one is one from Peru, where the devices are being used in about 70 different hospitals across the country. And then at the bottom, this is Henry Garvin from Gerona Hospital, who were supplied devices through the IMET 2000. And in both cases, having access to the devices has made a real difference to the number of patients and how they can treat them when they've got severe COVID. Finally, we couldn't close without a vast number of thanks. It's too many to really list at this point in time, but we've been extremely grateful to have support and have the opportunity to work with a whole range of people from a whole range of sectors. And we're very grateful for their ongoing support in many ways. And thank you very much for your time. It's a real pleasure to have been able to tell you about what we've been up to, and we'd love to answer any questions.
Well, thank you so much. What an incredible story, and the speed with which everything took place, and the amazing synergism between what would seem to be very different entities, Mercedes cars and acutely ill patients. We're a bit short on time, so I just had two questions really. One is, and this has been said to me quite a few times, and we've also experienced it, this showed that the system can actually move quite quickly to get things approved, which is actually not most people's experiences. As you say, I think, Becky, this can often take quite a while. So that's one question. Have we learned from this that we can speed up innovation and getting things actually to patients? And the second, which is for Mervyn really, is about, will this change what we do on ITU? Will we use these devices a lot more than sticking people on ventilators, and thereby actually keep ITU beds per se free for people who really do need ventilation? So those are the two questions.
Thank you.
So I'll comment on the first one. So I think you're absolutely right. So we managed to move extremely quickly, and we had an extremely positive experience, both in terms of cutting through kind of bureaucracy within the university and hospital, but also working with the regulator. So we were talking to the regulator daily from day 2 of the project, I think. So that was a very kind of open communication. They have very clear guidelines and criteria on, safety and efficacy that we had to meet, but they essentially pivoted all of their processes to enable this kind of rapid approval of devices. In terms of can this be done moving forward? So I think it certainly could be done, and it should be done. But I think we're at real risk that we're already really reverting to the way things were beforehand. So I think there's a lot to be learned in the appropriate and constructive fashion. But I think we're at risk of not maybe taking on board of all of those learnings at the moment.
Yeah, no, sadly, yes, from me too on that. In answer to your question, well, CPAP's actually been around a long time, and it's actually very well enshrined in intensive care practice. I think a good thing about COVID, because I think there was a lot of paranoia, the aerosolization risk to the healthcare providers and so forth. But again, sadly, nobody had bothered to talk to China and Italy about their experiences. And I've got lots of mates there, and basically they were using it, and the healthcare workers were safe. So I think we I suppose gave the impetus to say, look, it is safe, it is being used safely. But I think importantly, traditionally in the UK, CPAP's been essentially done on intensive care units. With COVID, we were able to move CPAP to the wards. And so a lot of hospitals around the country had respiratory high dependency units where they managed these patients brilliantly. And clearly, if the patients weren't coping, they could then move them into intensive care. So they did a wonderful job in decompressing us. And so I think that learning curve can be continued, and it is being continued, which I think is a positive.
Great. Well, thank you both very much. A very inspiring story. Reminded me of Apollo 13, where they had to sort out how to get the spaceship back. So thank you very much for a fantastic talk. And thank you also to Richard and Rosetrees for helping support that. So let's move over now to Neil. So Neil Greenberg is a consultant academic occupational and forensic psychiatrist based at King's in London. Neil is very familiar with tricky situations where things are happening rather fast. He's been in Iraq and Afghanistan, and it's part of his role as a psychiatrist and researcher, and he's going to talk to us about the impact of COVID-19 on the health of the NHS workforce. So I'll be interested to know how this has impacted on me. Over to you, Neil.
Thanks very much indeed for asking me to speak. So I'm going to talk to you about a study which kindly Rosetrees has part funded called NHS Check. Now, it might surprise you to know that although the NHS is a huge organisation and everyone has spoken about the mental health of healthcare staff for many years, actually before COVID struck, we had very little good, high quality data about the mental health of that important workforce. And so what happened as a result of the pandemic is we were able to pull together a cohort study looking at the mental health of healthcare staff in the NHS in England, and importantly, also trying to look about what the impact of COVID was and what might make a difference. So the study is the UK's largest one. We have over 20,000 people within the study across 18 trusts. And we very quickly saw that as this pandemic was going on, that mental health was going to be a very big factor, both as the pandemic was going on, but of course, it will continue to be an important facet of the pandemic as time goes on. So we were able to get some funding, which we started through King's College. They funded us to start up, and then we managed to get some other money. And we looked at all staff, not just clinical staff, because very much like when you speak to NASA and ask the person there who's sweeping the floor, what are they doing? And of course they say, I'm helping to put people on the moon. There's no doubt that everybody in the NHS has a part to play in providing healthcare. It's not just the people delivering the interventions at the front line. So we started surveying staff, within a month or two of the pandemic starting, and we are continuing to survey them. We've surveyed them at 6 months and also at a year. And we've also done some interviews. What I'm going to show you now is some of the results of that. The reason this is important isn't just we need to know about the mental health of the workforce, which clearly we do. It's also that if you happen to read the Daily Mail, and I would strongly recommend that you don't, it's good for fish and chips and not a lot else, is that you see lots of rather worrying headlines there, which suggest, we have a burnt out workforce, we have a ticking time bomb of mental health problems and all these other doom and gloom statements. And what we wanted to do with our study is to try and find out the truth, because that will allow us to plan going forward to what the true healthcare needs are for this important group of people who've done an amazing job. So overall, we've got just over 25,000 people in there. Now, this 17% response rate, for those of you who deal with big studies, you could see that and think, gosh, that's terrible. And you might not be wrong. However, this is by far the best response rate that you get in studies of healthcare staff. One study that was quoted a lot in the media at one point was done by the Royal College of Surgeons, which had 900 people out of a workforce of 1.4 million, and it quoted statistics about how many were ill. So whilst this is not a fabulous response rate, it is actually rather good for looking at healthcare staff who are busy and don't fill in surveys. And what is important here is actually what we've got is a pretty similar demographic. So it looks pretty similar to what the NHS looked like as a whole. There are some slight differences, but if you look at nurses here, we've got exactly the same percentage of nurses in our sample as you have in the NHS as a whole. So it's slightly different, but it's pretty representative of what the health is like. Now, when we look at what the impact is, and you can see here, this is our different trusts that we have in the study. These are the scales that we've used. We've measured common mental health problems. We've measured anxiety, depression, alcohol, post-traumatic stress disorder. And we've also looked at something called moral injury. And moral injury, I'll talk a little bit about it later on, but is a really important topic that has come up time and time again. Now, when we try and look about what seems to protect people, these are the aspects of NHS staff which seem to be associated with those who do better. So you can take it the other way around, in that those who aren't in this group appear to do worse. And this is quite important, because if we're going to focus interventions, we want to try and focus on the people who are particularly at higher risk of suffering mental health problems. Now, this looks like a really complicated graph, and I'm not going to go into the detail, but what this is trying to show is that actually what you can see here is, as time's gone on, this is April through to January, that actually, if you can, with the eye of faith, see where the first sort of peak was, and then things began to get slightly better, and then they began to get slightly worse again. And this is really important, because what it tells us is, yes, there's a lot of symptoms out there, but what we can expect is, as the intensity of the work gets better, so should people's mental health, without necessarily the need for lots and lots of interventions. There will be some people who do need help, but the workforce mental health generally should get better as the intensity of the pandemic goes down. Of course, the other side to say is that if it doesn't go down, then we expect it to stay high. Now, our study here, this is our findings overall. These are the rates that we find. This is looking at previous studies and the general population. So what we want to do is not just say how 50% of our study appears to have mental health difficulties generally. We want to say, how does that compare to other studies? Well, so that's slightly higher than we would find internationally in healthcare workers, and it's higher than studies done during the COVID pandemic in the UK population. So we see sort of nearly a doubling. But actually, when you look at it in more detail, the anxiety and depression pieces are actually pretty similar to the general population. And overall, what we're finding seems to be that the sort of biggest impact here is on people who may have post-traumatic stress disorder. So we're not saying these levels of anxiety and depression are low, because they're quite high, but they've been high in the general population during COVID as well. And this is a particularly high figure. Now, the study that we've done, it has lots of strengths. It's large. It's able to look at not just clinicians, and because we've got data on who has and hasn't completed the study, we can begin to use statistical techniques to tell us more about how the whole population would look. But it is a low response rate, and any study that uses self-report measures, and our team uses these a lot, we know that actually they can overestimate the truth. So if you fill in a self-report measure and you are really upset when you go to the doctors and fill it in, you can put really high scores, and they don't necessarily mean you're unwell. And so what we've done here is we have really importantly conducted some really careful interviews with people in the study to try and see what does the score they give on the questionnaire actually mean in terms of illness. And this is really important because without that sort of careful analysis, what we're not able to do is to predict what the treatment needs are for staff in the long term. And so what we've done here is we've carried out these diagnostic interviews. And if you remember just back a few slides ago, there was about 24% in the sample, so almost a quarter, who appeared to have PTSD when you gave them a questionnaire. But when we've looked here, this is called the clinician administered PTSD scale. So this is a clinical interview for PTSD. About 9% come out. And what that tells us is actually a large proportion of the people who appear to be distressed on questionnaires are actually people who have symptoms that are distressing, but they're not indicative of being ill. Now, this is important because what that tells us is a lot of those people will get better with good management, with good general support. But this 9% figure here tells us that this proportion are likely to need some sort of care or treatment. Now, how does that compare with the general population? Well, it's about double. So good studies done in England previously show that about 4.5% of the general population have PTSD. So what we're saying here is that healthcare staff have double the rate. And actually our department also does a lot of work on military veterans. And this is a very similar figure, perhaps even slightly higher, dare I say, than military personnel who have been on deployments to unpleasant and challenging places. So this is an important figure, but it's not quite as high a figure as the Daily Mail would have us believe. And it's also not quite as high as you would see on questionnaires. Now, we talk about moral injury quite a lot, and what moral injury describes is this situation where you have to try and deliver care when actually you can't do it very well. So you're a critical care nurse, you're used to dealing with one patient at a time, but yet you have 4 patients to deal with. And you can easily and quite understandably say that's not right. And so a moral injury is something that violates your moral or ethical code. And what we've done in this study is to measure staff's exposure to morally injurious events, to situations that shouldn't have really happened. And these can be things that they did, things they didn't do, or betrayal, feeling betrayed by people who you should have trusted. And of course, the whole PPE piece was much about that early on. Studies we've done on moral injury before show that actually there's a link between moral injury and post-traumatic stress disorder, depression, and also weakly, but significantly with suicidality. And this is the scale we use to measure moral injury. So we ask people about these events that might have gone on that are just not right, that don't fit with their moral or ethical code. And the reason that one of our results that we found, which shows that this is important, is this is people who have low exposure to moral injury, moderate exposure to morally injurious events, and high exposure to morally injurious events. And this is different sorts of measures of mental health in terms of general mental health, depression, anxiety, and trauma. But the reason that this is important is you can see here is the people with the highest exposure have almost a doubling of the rate of probable mental ill health. Now that's important because staff who have been put in these really difficult situations are the ones who are most likely to have mental health problems. And it's important to remember it's not just those staff at the front line who have to make these difficult decisions. Speaking, say, for instance, to oncologists who haven't been able to treat patients knowing that bad outcomes will occur as a result of that, can also be put in this position. So this allows us to begin targeting interventions at groups who are increased risk. And probably the biggest reason that people suffer moral injury is feeling betrayed and feeling let down. And that can be by colleagues. Often it's by the trust or by the nation or by the NHS as a whole. And that says something again about the sort of messaging that trusts need to use to try and repair this moral injury, not just by saying, well, these things happen. So the conclusion overall, this is a large study, which thankfully has been funded. We found higher rates of mental ill health. They're not so high as to believe the Daily Mail. We've shown that moral injury is an important concept, and that's particularly because of betrayal. And what we need is to try now to find ways, using our data, which we have, to try and look about how we make these things better going forward.
Fabulous, Neil. Thank you very much. Such an important issue. And I think, all of us felt stressed when COVID came along, when many of us were ending up having to do jobs in hospitals, which we weren't that familiar with or hadn't done for some time. So there are a couple of questions. I just had one to begin with. How do these rates compare to a non-COVID NHS
That's such a good question, Roger. And of course, the problem is, as I said, is we don't really have very good data. So for instance, what we can do is compare it to some really poor studies that have been done in intensive care staff before the pandemic. And there you find rates of between 9 and 13% of people who might have PTSD in intensive care staff generally. And we're finding rates of about double that using our questionnaires. So it does look higher, but we have to be really careful because it's not just the pandemic, it's also the fact is living in the pandemic. You know, the whole general population had higher rates and healthcare staff are part of the general population as well. So it is hard to tease those out.
And there are a series of questions here about really, can we use this data to keep people in the NHS? Because obviously people might leave as a result of some of these traumas that they've had. So how can we monitor these patients long term? And then how much support can we give to keep people in the NHS feeling that they're loved and
cared for, hopefully.
Yeah.
Absolutely. Well, one of those bits that I haven't reported on yet, because I'm still looking at it, is we've also asked people about their use of different support measures. And that ranges from having a good supervisor who talks to you, or whether it's using a well-being space or phoning a telephone helpline or any of those sorts of things. And what we find really strongly here is actually the best support isn't lots of people like me coming in and providing therapy. It's having colleagues and line managers who are really able to talk about you. And that has fed back into the NHS, who are now investing not just in mindfulness apps, which have pretty poor evidence for most people, but they're investing in trying to build more supportive teams. So giving managers some skills about how to have psychologically savvy conversations. So our data is feeding directly back in to try and change the way that the NHS England as a whole is providing support now to teams rather than just to individuals. So we hope that that will make a positive difference.
And the final question was, how far does this extend out to the care home and the social care staff? Was this just within hospitals, or was it out in the community and care homes as well?
So this particular study is just within hospitals, but we are absolutely sure that the issues are absolutely the same in healthcare, in care staff, and actually probably more difficult because they have less levels of training, and also they're often more privately run, and so they don't have such a collective sense of, you know, an organisation that should be looking out for you. But yeah, another important piece of work that definitely needs to be done.
Well, thank you very much, Neil. Thank you for taking on such an important area of research, and we wish you all the success taking it forward, because obviously this is just the beginning of some very long-term research. So we now come to our final speaker of this afternoon, which is Adrian Hayday, who works at the Crick Institute, has a very distinguished background in tumour immunology, especially around T cells, and he's going to talk to us about learning how to treat cancer from COVID-19. So I hope you're there, Adrian, and you can share your slides. We can see the slide, but I can't hear you or see you. I can hear you. I can see you.
Excellent. Let's do that again. Right. So hopefully you can hear me now.
Yep, I can hear you. I can see your slides and I can see you. So thanks
Perfect.
very much.
Okay, so thank you first of all to the Rosetrees group for giving me an invitation to talk about some of the work that we managed to do during this unprecedented period. Thank you too for their support, and thank you too for what I think is a very enlightened attitude that they've developed towards the relationship between research and the delivery of healthcare. So I'm going to talk about how actually we learned something from COVID-19, much as though it wasn't necessarily the scenario we would have chosen to learn it. Before March the 13th of last year, my lab did not do count 3 investigations of the time that you see my researchers dressed up to work in here. But apropos what was said earlier about the speed with which things turned around, it was really quite remarkable and quite motivating to see how quickly people retooled and passed through all sorts of accreditation hurdles so that we were actually able to start looking at our first patients by March the 25th.
But what I want to do is just contextualize where we were before COVID came along. And as you've just heard, our interests have primarily been in T cells that enter tissues in the body for multiple reasons, but in addition to attack tumors. And I think it's clear to probably most people on the line that the introduction of immunotherapy into cancer has been one of the most game-changing advances in cancer treatment and a cause for renewed optimism in the last decade and a half. And these therapies go by various flavors now. Some are called immune checkpoint, others are called CAR T. And I'm happy to say that in our day job, just this past September, we began clinical trials of what we call gamma delta T cells. But in addition, there's been a long-standing interest in whether you could actually vaccinate a patient against their own cancer. The idea is that the genetic instability of cancers creates new proteins that the body could respond to. And so if you vaccinated an individual against them, then not only would they make a response that would attack the tumor, but they would have this long-standing adaptive antigen-specific memory of tumor-specific antigens that could potentially keep the cancer under control lifelong. And it was mentioned earlier that, of course, today has seen an all-party MPs report, which is certainly not heaping praise in large numbers of areas, but the one thing that does seem to get consistent praise is the vaccination program. So I can tell you, I don't think it's any secret that the government feels extremely bullish about this, and there's a lot of work going on to see whether this kind of success of vaccination could be indeed applied to cancer patients. It is important to remember, of course, let's say it now, that when you vaccinate an individual against a virus, including the COVID-19 virus, SARS-CoV-2, that individual is healthy. To vaccinate a cancer patient means essentially getting an immune modulation to work in an individual who is rather sick. So the question is, what is the immunological status of a cancer patient? Which leads to a bigger question, which is how do you actually assess immune competence in humans? It's kind of remarkable to think that you can go along to your doctor and have a liver test, you can go and have a renal function test, of course, a heart test. But actually, if you ask your doctor to measure your immune competence, that's not going to get an easy answer. So Mark Piedmont and I raised this issue getting on for 15 years or so ago. And then there are a number of conferences, including one at the NIH at the time in the United States, that seemed to galvanize a lot of interest in this space. And a sort of science capacity was born that tends to be called systems immunology, whereby we have high throughput, high content ways of measuring lots of parameters and quite high powered data analysis and machine learning that enables us to learn patterns that tell us something about the immune competence of individuals. I should say right away that this is still very much in its infancy, an issue that I will return to at the end. So having built this capacity in London, and that was supported by the Biomedical Research Centre at Guy's and St Thomas's in partnership with King's College, we were in a good position, as I mentioned already, on March the 13th of 2020 to think about deploying it to a COVID-19 cohort, mostly in St Thomas's Hospital, where, of course, during our study, we also were joined by a particularly famous patient, the Prime Minister himself. So I'm not going to go through all of the details of this study at all, but suffice it to say we were able to look at large numbers of people with varying ranges of severity, also be able to look at recovered, healthy individuals. And for every blood sample we took, we essentially got back 600 data points. And you will, of course, recall in those sort of remarkably daunting times of March and April 2020 that none of us really knew why people were getting sick. Were they even making immune responses? Or were the immune responses actually killing the individual? So we didn't know what we were going to find. But we went in, and to cut a very long story short, we saw, for example, if you look here, the yellow are patients with varying degrees of severity. You see certain types of cell massively increasing. These are probability values here, this one being quite astronomical relative to what you'd see in a control patient. And then you see, again, huge increases, for example, these very severely ill patients of these cells, which are known as plasmablasts. They're responsible for antibody production. And what you can see is pretty much everybody was making antibodies. Antibody failure was a very rare beast in COVID-19, a point, again, that I'll get back to in a moment. So to sum this up, a signature immune response was associated with COVID-19. The response included things that the textbooks would predict we would see, but actually a lot else was going on in the sort of battle zone of infection that no textbook that I know of actually either describes or predicts. So we were learning fundamental new immunology as pertaining to humans that we'd never really had the opportunity to look at before. And again, in terms of speed, we were able to write this work up, and this was published in August of 2020. Again, an experiment that started on March the 25th. If my life had been full of Nature Medicine papers turned around in that time, then I probably wouldn't need to be here anymore at all. So this was quite unprecedented, but we wanted to use this capacity at the same time to ask an even deeper question that I've already alluded to, is what's the status for a cancer patient? So cancer patients, for all sorts of reasons, were considered to be at high risk. One of them's already been alluded to by Neil, which is, of course, that if you've got COVID-19 and hospitals are shut and all sorts of issues are going on, you're actually not going to get your cancer treatment. Well, suffice it to say, we put together cohorts who had solid cancer or hematological cancer, and were able to make a lot of comparisons again. And that work was published online in December of 2020. And what it basically showed, and this is a very symbolic diagram, I realize it's rather minimalistic, but it basically shows that these solid cancer patients here, relative to, for example, cancer patients who do not have COVID-19, are showing changes in a number of immunological parameters. These are going down, these ones are going up, that are very similar to what you saw in COVID-19 patients who didn't have cancer. So actually the cancer patients were doing pretty well. The hematological cancer patients, I've got some examples here, did a bit worse. But if you look at antibodies here, again, you see the solid cancer patients are making plenty of good antibody. The hematological patients, again, in fairness, a bit worse, but nonetheless, there were some grounds for optimism. So we can conclude that a COVID-19 associated immune signature response was displayed by cancer patients. Quite remarkably, even those with stage 4 disease that were being treated with palliative intent. So the idea that cancer patients are simply generically immunosuppressed because of their disease or their treatment was really not right. Blood cancer patients showed somewhat less immune competence than solid cancer patients, but it wasn't awful. So then, of course, we entered the era of the vaccine, which was scheduled to start on December the 8th, which was clearly designed to basically ruin Christmas for researchers such as ourselves. But then again, Boris ruined it anyway a few days later, so it didn't really matter. We had nowhere to go except work. So we looked at the response of cancer patients to vaccination, a study that was really masterminded by my colleague, Shipley, a young oncologist at GSTT. And what we found really surprised us, because if we looked at solid cancer patients, when they got a single jab of the vaccine, and these are their antibody responses, they did actually a lot worse than when they got infected. And hematological cancer patients were a complete disaster. So actually, if you look at efficacy, this vaccine, this is the Pfizer BioNTech vaccine, 94% of healthcare workers respond to this. It's a fantastic vaccine. It's brilliant. Less than 40% of solid cancer. And over here, down here, 18%, less than 20% of blood cancers. Now, for solid cancers, the good news is that some of these individuals got the boost in 3 weeks before the government changed its regulations, and now it went up to 95%. So boosting looked kind of good, but nonetheless, what this said was between the first dose and the second dose, there really was a window of vulnerability, which was exacerbated by the change in policy to delay boosting. So I'm happy that this work, which was significantly funded by Rosetrees, actually ended up being cited as influencing the Green Book based on the Joint Committee for Vaccination and Immunization. But of course, when they did get boosted in the end, after 12 weeks, we could look again. And still, the sad fact is that less than 50% of hematological cancer patients are getting protection even from a second jab. So the country may have become quite blasé to the potential for the transmission of this virus, but I'm afraid to say there's large numbers of people, there's 500,000 blood cancer patients in this country. There's large numbers of them trying to hold down jobs, go about their work, go about their business, having to deal with crowded trains where people don't quite show the respect they once did for health compliance, and they know that they're very often unprotected. So blood cancer patients with very poor response, as I said, and they boosted rather poorly too. However, what is really interesting, it's in the same study, we were able to ask, well, how do these cancer patients respond, for example, when we asked them to show responses to flu, to EBV, to tetanus, to CMV. These are viruses that these cancer patients will have seen before. And the answer is brilliantly, their responses were just as good as anybody on this line. So these patients do not have generic immunosuppression, as is consistently said about cancer patients. They have a unique failure to see new antigens. They were highly susceptible to West Nile virus when it first appeared. So now what we should really realize is that if we're going to get cancer vaccines to work, there should be regular immune profiling of all cancer patients to understand what it is in concert with fundamental research that makes these patients uniquely difficult to get to respond to a new antigen as opposed to one they've seen before. And we need to design these vaccines accordingly. There's more people to thank than I could possibly do. What I would say is we put all this on our website, which is open access, www.immunophenotype.org. So I would encourage people to visit it. We speak quite a lot about different things there as well, but I'd be happy to take questions. Sorry if that went over a little bit.
Thank you very much, Adrian. Fantastic talk, and amazing how you can take sort of expertise in one area and quickly transfer it into another and learn so much. So we're a bit short of time, but there were just a couple of questions. I had one which was about, I mean, a lot of people say that the immune response to COVID is no different to an immune response to any bad infection. But what you're saying is that it is actually different. So your immune response to COVID is different to someone else on ITU who just had a bad.
Yeah, so we actually were able, Thomas is a pretty big ICU. So we had current patients on severe lower respiratory tract infection. And of course, they have signature immune responses of their own, but they're quite distinct from the ones to SARS-CoV-2, which look a little bit like sepsis responses, but they're not sepsis responses either.
Okay. And there was a question here about why do the blood cancer patients respond so poorly to the vaccines? Because I saw on the slide you had things which didn't associate with it, but what is it that
the simple answer is we don't know, and the answer to the message to Rosetrees is just keep pushing on, because for all that's been written about immunology and for all the books that have been published and the people that speak about it, the question of why it is that it's hard for a blood cancer patient to recognize a new antigen when we can ask them to show us they've got T cells and B cells against things they've seen years before, and they do that brilliantly. We don't know, and we need more fundamental research to find out. But the results of that research can help us design vaccines that could make cancer vaccination a possibility.
Well, thank you very much, Adrian, and thank you, Neil, and thank you, Becky and Mervyn, for 3 amazing talks that we've had this afternoon. Been a fantastic walk through some of the great work that's been done in COVID and which has been funded by Rosetrees. So thank you all very much. Splendidly inspiring talks, and amazing how things can move so quickly and so informatively when everyone comes together to work around a common problem. So it just leaves me to hand over to Anne, who I think wishes to say a couple of things. I would also, just before I hand to Anne, like to thank Richard and the Rosetrees for the way in which they have organised their funding of research in the UK over, I've been privileged to be involved with it for about 10 or 15 years now. It's made a fundamental change in how research can be done with the way in which they've employed their funding. And Richard in particular, who personally funds all of this, it's been a wonderful contribution to British science. So thank you very much. So Anne, over to you.
Thank you very much, Roger. And first of all, thank you to you, Roger. I mean, you've been such a great friend and supporter sitting on our scientific advisory panel and giving us brilliant guidance along with your colleagues for so many years. So, and thank you for your chairmanship today. But to our speakers, wow, what do I say? I mean, you're absolute exemplars of our strapline, which is helping brilliant minds discover solutions. And you've all stepped up when the pressure was on. I know how, well, speaking to you in the early days, the amount of work, the hours you were putting in, the immense stress you were under, having to run around finding collaborators and finding not just our funding, but other collaborative funding to just make it happen. And you weren't going to take no for an answer. And you really are brilliant, perfect examples of British research and this sort of ability to be able to pivot quickly, find people you can work with, do it quickly and do it with a smile on your face. I mean, I know Becky was telling us about how some of the people came to UCL and came with their toothbrush and a pair of underpants and they didn't go home for 6 weeks. That's true dedication in my book. So really congratulations and thank you all for your amazing time. Adrian, I hope you get a decent Christmas this year and that Boris doesn't disturb it again. And we will certainly keep pushing on. I mean, we have huge ambitions for the future. We're very positive about all of our researchers, not just COVID, but everybody who feeds into the system. Everyone that plays an incredibly important part. I just want to pay tribute to a couple of other people. Obviously, Richard Ross and another co-funder that we work very closely with, David Taglight from the John Black Foundation. They had the foresight to say, let's not slow down, let's make funding available immediately. And we all put our shoes on, ran to work and worked incredibly hard to get the money out of the door. But we couldn't have done that without the amazing support from Professor David Katz, who organized huge reviews in very, very quick, speedy fashion. I know he was burning the midnight oil continuously, getting everything out as quickly as we could. And without his help, we couldn't have reviewed the applications and made it happen. And we did it very, very quickly. And really, I think it's just hold your nerve, everybody, keep going, because we really need everything that you're doing in so many different areas. And it's an absolute privilege to support everybody. We've enjoyed it immensely and we enjoy everything we do and we just want to keep going. So thank you very much again for all your time today. And be well. Bye.